The concept of class inclusion is very difficult for middle school students. By class inclusion, we mean the idea of taking a quadrilateral and also calling it a square, a rectangle, and a parallelogram all at the same time. Here is a related SOL-type question that talks about class inclusion when asking about a quadrilateral. Margie, what can we do with our students to make the idea of class inclusion a lot less difficult?
Well, for example, in dealing with quadrilaterals, I like to use a manipulative to illustrate how one category can be part of another category. Here we have a figure. Now let's examine this figure. I can flex it back and forth so that it's going to look different. Can you tell me some of the names? What can I call this figure that has four sides?
Well, a figure that has four sides is a quadrilateral.
This is a quadrilateral, yes. Now, what other name might we apply to this particular figure?
Well, I noticed that the two blue sides are parallel to each other and that the two orange sides are parallel to each other, so I guess that would make it a parallelogram.
Yes, it is a parallelogram, but is it still a quadrilateral?
Well, yeah, it still has four sides.
So it still is a quadrilateral. Now, as I move this back and forth and sort of flex these angles here, flex these sides, I want you to make some observations about what stays the same and what changes.
Well, I noticed that the sides are not growing. The blue pieces are still the same size, and so are the orange, so I guess what stays the same is the length of the sides.
Very good. And if the lengths of the sides are staying the same, then the perimeter must stay the same. How about the area?
Well, that's changing in the middle.
Yep, the area enclosed in this quadrilateral is changing. Now let's focus on these angles for a couple of minutes and tell me, what do you see as the angles are changing?
Well, it looks like the angles that are opposite each other are the same size, and when they change at the same rate, that they're still the same size.
Yes. So this angle is congruent to this angle. Same way this pair of opposite angles, this one and this one, stay congruent. And even when I move it, we still have the opposite angles staying congruent. Now, what about the total of the interior angles in this quadrilateral?
Well, the sum of the angles in a quadrilateral is 360 degrees.
Okay, we can really illustrate this very well by putting in a diagonal, because the diagonal separates the quadrilateral into two triangles, and we know that each triangle must have 180 degrees in it, so 180 plus 180 gives us the 360. Well, let's try something else here. Let's try fixing one of these angles to be a right angle. I can check that either by using my angle ruler to measure to be sure that's a right angle, or I can just take a simple object like a file card that I know has a right angle and put it in and fix the angle to be a right angle. Now I'm going to hold this to be a right angle, and I want us to think about what happens to these other three angles. Are they right angles?
Well, the angle opposite the right angle that your finger is on has to be a right angle, because we already said that the opposite angles were equal.
Okay. Now, what's the total of the four angles?
360.
And we've already used 90 degrees here and 90 degrees here. So what's that leave?
180.
Okay, so we have 180 left for these two angles, but what do we know about those two angles?
Well, they're opposite, and we already said that opposite angles are equal.
Okay. So 180 divided by 2 gives us 90. So we have a 90 degree angle, 90 degree, 90 degree, 90 degree. What name can we give to a quadrilateral that has four 90 degree angles?
Well, that's a rectangle.
Is this rectangle still a parallelogram?
The blue and the oranges are still parallel.
Is it still a quadrilateral?
Yes, it still has four sides.
It still has four sides. So we can apply many names to this same figure.